Good afternoon, everybody. It's 3 o'clock. We're going to go ahead and get moving on this. You see the sign-in code here. Go ahead and either snap a picture of it or copy and paste the link down here. That gives you your sign-in, and that's if you want any CEU credit or NATE. Um, You'll enter it on there for the NATE. If you don't have NATE, go ahead and just put NA. And then over here, we got the quiz QR code, same thing, and the link for the quiz. So go ahead and snap those, and I'll put those back up later during the break and at the end. So welcome to spring training, ductless installation and troubleshooting. Hang on here, bear with me just a moment. I've lost part of my presentation. Brief explanation, and if you've spoken to one of us before, especially when it comes to me or Craig, you might specify which one you have spoken to. Now, we all know there's been a few changes. So for the ductless, it's me, Craig Duty, and I also do the geo and small packages. We got Craig Kabler doing 90%, 80% furnaces and non-communicating thermostats. John Jones up in Omaha, AC heat pumps, fan coils, electric heat. Steve Wright and Lenexus doing commercial equipment and BMS controls, and Rob Roach is doing Infinity controls and indoor air quality and parts verifications. This is mainly just for the Kansas people. Craig's already sent out the enrollment sheet and evaluation sheets to you. Go ahead and submit those and return them by March 31st, so we can get so he can get everything turned in and get your certifications through there. Once again, if you need to ask any questions, do it through the chat, and we'll get to moving here. Ductless single multi-head units, troubleshooting and installation. Correct tool for the job. A good digital meter, multimeter, capable of reading AC, DC volts. Mega ohm meters is a good idea, or a multimeter capable of reading mega ohms. Also, most manufacturers have small probes, needle probes. This will help you get into the tight spots on the Molox plugs, and it's not just for the ductless on that. I mean, our rooftops have them, furnaces have them, regular heat pumps and air conditioners all have these Molox plugs, which are really small. And if you force your larger probes in there, you could damage something. We don't want to damage anything, just trying to do diagnostics. Good sharp pair of wire strippers. That'll keep you from having a little bit of these extra wires over here, which can cut down on your communication. Also, we got a debugging tool. This is the RCD code, our part number for it. I have not personally used it. I hear from the factory guys that it works really good. So just let you know that's out there. You can contact us, or not us, but the counter, and they can get in touch with you further on that. Why do we want the correct size of system? Well, choosing the correct size and the right type of equipment is a critical part of installation. You always want to refer to your product data to see that the certain equipment operates together, see what its temperatures and BTU ratings are. And one thing to remember when you are installing ductless systems, always remember they are variable speed. They do not operate like conventional heating and cooling equipment. Correct size and type of installation is very important. Where the application is. Remember, these are variable speeds, so the heating and cooling outputs are not set in stone. For example, 9,000 BTU output for the heat can be anywhere from 4,500 to 14,500 BTUs. And in the cooling, it could also be anywhere from 3,500 up to 13,000 BTUs. So once again, like I said, they're not set in stone. And you want to refer to your product data manual for this information. Another thing to think about is ductless all have a minimum runtime about 7 minutes, and this is for oil return. And this can cause overheating and overcooling. Sometimes this overheating and overcooling can be adjusted in the temperature compensation settings. Multi-head units, there's also bleed by because the EXVs do not close all the way. There are some other things that need to be taken into consideration when sizing. And just remember that these are heat pumps. Most of them are air conditioners, and they do have limits. We want to, on this example, we're going to try to keep our room temperature around 70 to 75 with an outdoor temperature of 10 or to 93. And we all know it can get well above or well below these numbers. Just take that into consideration. And don't forget about location, like a bonus room, garage, if you got high ceilings. Maybe surrounding factors like if the windows, good insulation, good doors, shade, if they got good shade. Is this their only source of heating and cooling? For this example, we got a 7,721 BTU for heat system and a total cooling of 8,059. Now remember, these are variable speed units. And for multi-head systems, you'll also need to do a load calculation for each room. I had a few rooms where they are large enough they have two separate heads in there. Like if it's a large enough room and you need 2 tons of cooling in there, you're going to think about putting 2 different heads possibly in there, depending on how large it is. Performance charts, you want to look at your product data manual, making sure that choose the equipment that'll do the job. Extreme temperature swings. In the winter time, we got a required heat of 7,721, and we got our total latent heat gain here of 896. And during extreme temperature swings, this efficiency on these systems can drop. For example, we had these low temperatures here in February, and in some cases, our units, while they were heating, they were only running 65 to 70% of that heating. Meaning, if for example, you got a 12,000 BTU unit, you're only putting out 9,000 BTUs roughly. So take that into consideration. Also, make certain they are compatible with the indoor and outdoor units. Always refer to your product data to help out with your selection, to see which one you're going to take. In some cases, like for the cooling temperature, it's not if it's not on the chart. I hear say you got 96, so you want to go up, or even 98. If you got 100, you want to go up one rather than go down. This will help the performance and the overall sizing, and you'll take into consideration the variable speed on that. And for heating, same thing. Say if it's you're sizing it for like 1 degree. So you want to go down, you'll want to go down to 0. Um, just remember these heat systems, the temperature drops below 10 degrees, they start losing their efficiency. They will compensate for it by slowing fans down, slowing the variable speed down, not putting out as much heat, but still heating. Another consideration is air throw, especially on the high wall systems. Depends on how long your room is. If it's wide, you want to consider how far it can go down there. You don't want all the air at one end. You want a good balance. See right here on the 9,000, 12,000 BTUs, it'll throw it approximately 23 feet. So minimum of 11, approximately, 23 distance. And you want to refer to your product data manual to know this. You also must take into consideration the location of the indoor unit. Make sure you get the best coverage. Location of the outdoor unit to prevent damage from ice and snow. Consider drainage. If a condensate pump's needed, or you're going to go gravity. Wireless remote, wired controller, 24-volt interface, Wi-Fi. Want to think about all those. And we're going to move right in here to installation of tools. Most of you guys have these, whether they're at your shop, installation van, truck, what have you on that. A couple things we're going to point out here is a good flaring tool, or a good deburring tool, in order to get the burrs off there. A good burr or a bad burr on there will make will make you have a leak, and a nice smooth one will give you a less chance of a leak. You can also put refrigerant oil on a nice good one to help it seat better. You want to use a torque wrench and a backup wrench to make certain you have the proper torque and the good connection, and you can refer to the installation manual for the correct torque settings on these flare nuts. This down here in the corner here, that's an example of a bad flare. I guarantee you that's going to leak. Deburring tool was not used. There's a nice smooth one there on that one. You want a nice sharp pair of tubing cutters. For flare conversion, if you got a larger pipe coming in, especially on the multi-head units, these conversion joints, they come in the loose bag of parts, different sizes for different lines. Any size of unit can be connected to any port. Just remember the right number. It is recommended that you put the largest unit on port A. This is a good idea. It helps in heating performance. But if all the heads are the same size, it's not going to matter as long as you know which one's going where. Pressure check is always recommended. You go up to 500-600 PSI minimum for an hour. See if it leaks. Remember, an evacuation does not replace the pressure test. Triple evacuate the system, pressurize it. When pulling a vacuum, you want to consider your moisture level outside. For a single zone connection, you want to go down here at this port, the suction line, low side port, and on multi-head systems, you want to come up here and attach your gauges to there. And then when you do that, you can open up whichever valves you have, or all of them, whichever ones are connected to the indoor units. And you will have to allow time for each circuit to pump itself down. You want to refer to the installation manual for how much refrigerant needs to be added to this system, if any. Take into consideration height, length of line set, you're looking for. And then when you break the vacuum, you want to use that extra refrigerant to break the vacuum with. Here's a ductless evaluation sheet. We can email you this. I can. Any of us can, and sometimes this will help you guys diagnose maybe what the problem is. Other times it'll help us diagnose what the issue is. And like I said, we can send these to you. There's a wide variety of outdoor units available in the heat pump and air conditioning, 24-volt interface, single zone, multi-zone, heat pump, air conditioner. The 38 PRA Infinity and Evolution systems. We got an auto restart function, inverter compressor, built-in Wi-Fi, wireless controller. Just to mention a few things, refrigerant leak detection on there. Just a wide variety of features on the Infinity and the Evolution systems. You always want to refer to your compatibility charts for particular models. When you are installing them, you want to be certain they can talk to each other and they work together. And this is especially true on multi-heads, multi-zone systems. Surge protection, if you got a voltage issue, problem, or just want to protect the system, if you have a lot of brownouts, fluctuation in voltages, you might consider installing a surge protector. If you have unexplained compressor and board failures, it might be the fact that your incoming power is doing something and you're not there to catch it at that time. And this is a good idea to install these and help protect the system. Now we're going to get into some troubleshooting of the more common error codes we get. We're going to go over a few components operation, a couple tips when you're troubleshooting ductless systems. 1, they do not operate like conventional systems. 2, do not immediately attach your refrigeration gauges to these systems. You can only tell if you can only tell if the system has refrigerant. You can't tell if it has the proper amount at this point. You always want to refer to your service manual for detailed troubleshooting on all error codes. We're going to jump in here to the MGR units and for diagnostics. On the high wall systems, you can see they have a display, and a lot of times the display is just telling you what it's doing, like DF is defrost, preheat, oil return, things like that. So it is just telling you what it's doing, not necessarily that it has a fault code. On the 38 MGR, you go outside, you have a little SW1 button next to the display, and you push that once and it'll tell you, indoor, how many indoor units you have, which ones are working. The second time you push it, it'll tell you what mode it's in, the number of capacity of the units. This is a good idea because this will tell you, what your capacity of your unit is, because just because it's running doesn't mean it's running full, or if it's running, half, or it's a certain percentage. This will also tell you what your various sensors are doing. The 38 MBR, this also gives you an idea of what the outdoor unit is doing, along with what the sensors are doing. All this information is available in your service manual, and I will refer to service manuals, installation manuals, and product data manuals quite frequently. Automatic wiring and piping fix. This is a good way to test, especially on multi-head systems. You could have something crossed. However, the main problem with this is it's not recommended. It's preferred that you physically change the wiring to match the piping. And the reason for this is in the future, what if you have an outdoor board go bad, or you have to change out that outdoor unit? So you change that, and the new board has no clue what's going on. And all of a sudden now you have all sorts of communication errors, and it's just easier for down the road purposes to just change the wire right then and there. If you have an error code indoors, you want to go outdoors and make sure that error code matches. You'll refer to your service manual for this. Some of these outdoor units, they have a display. Some of them have blinky lights, so you'll have to decode what those the blinking lights are. Some of them also have several color of blinking lights. We're going to get into the IPM malfunction, temperature protection, compressor, the P0, the discharge error, the P4, and the IPM module protection of a P6. Now, it's a good idea if you walk in on this and you find out that you have a code that starts with a P, it's best just to go on outside and see what's going on outdoors. One of the more difficult things to do, and I've talked to many of you about this, is finding the P and the N on the control board, and this is crucial for testing the control board. Some ideas of where to find the positive and negative side of the board, back side of the capacitors, where they're outlined in a circle here. And you can see the circle indicates the capacitor. The positive side of the capacitor is here. And it's usually if you have the picture, you can see the one for the positive side kind of has the rectangle there. And then on the negative side would have the half-court basketball to just make it easy. And, you're going to be looking for the plus, the minus, the positive, the negative, the P and the N, and you might have to pull the board out and flip this board over and take a look and see what you got. And then you also want to take into consideration that you have a coating over these solder joints. You have to do a little bit of scraping to get that connection good. And here's just a few more examples of where to find these multi-head, single-head units. And it is one of the more difficult things we have to do because we don't always have a layout of where these are on the board. And the boards do change from board to board sometimes, and we don't know where they're at. Now, if you can send us a picture, usually we can find that pretty quickly. I'll walk you right through it, which is where that text number comes in handy at. When troubleshooting an error code, you want to look for burnt spots, damaged wiring, loose connections. We usually start with one of the three, not one of the three, but one of the four components, condenser, fan motor, compressor, main board, or driver board, depending on which the error code is. Those are the ones I like to start with if we don't have a visible blown out board or anything visible. This way here, this eliminates the big ones, and then we can move on to the other ones. So this is where your needle probes will come in handy off your meter. You can find you go to DC voltage. Just flip your meter over DC voltage. You're going to put your red lead on positive, black on negative. You're going to have this thing powered up. And you're going to see what your voltage is on the P and the N. That's why P and N is so crucial. It's for testing purposes, and you're going to have to refer to your service manual to find out which one, where you're supposed to be at for DC voltage, because it does vary per model and per size. IPM continuity check. This again is where we are looking for the P on the control board. We're checking for resistance when we get to this board. We're not looking really for any set resistance. It's just we're looking for a consistent resistance. And we go for, you put your red lead on the P and you move the black one between the U, V, and the W. And they need to be pretty much very close to the same. And if you don't get anything, it's possible you don't have a good connection. I always recommend to at least do this twice, maybe 3 times, depending on how much coating they've put over it. Here's another good location. You got the UV and W, the P and the N. I mean, up here is a small, different capacitor. I prefer to find the larger ones. They're just easier to deal with. You do want to make certain your unit's been off for 10 minutes. This allows the capacitors to discharge. Um, Once again, we're checking for resistance, not a specific amount. And these do fall within the mega ohm range. And once again, you'll put your black probe on the UV and W on the IPM and your red on the positive. And you're just looking for a consistent resistance. And here's just some locations. I mean, there's your capacitors, your half quart, uh, P for positive. There they give you the P and the positive sign. This is just one of the harder things to do, is finding that P and the positive, because chances are pretty high you're going to have to pull that board and flip it over. Now, if you're reading, if you're on the P and the N and you're reading negative voltage, you want to switch your meter leads around, flip flop the black and the red, because you want to read positive between the leads on the P and the N. Now we're getting to P0 and P4 codes. This can also be caused by a bad IPM board or a bad compressor. You want to check the board, check the compressor, check the ground. There's some more items to check, but these are the main ones we check first, just because they're usually the ones that take the brunt of the damage. Remember to always check for loose connections, possible burnt wires, mice chewing through them. When checking the compressor, you can check out the UV and W for DC volts, and you're going to refer to your service manual for the correct readings of what these are. And we'll get into the compressor checking here in just a moment. Low refrigerant charge or restricted airflow can cause P0, P6, P4 code, and cause several different types of code. Causes the compressor to overheat if you're low on refrigerant charge. And this is the main reason for compressor failures, is low refrigerant charge. Proper installation, good flares, good cut and deburring can prevent a refrigerant leak and save a compressor. Now, there's only one way to verify that you have the correct charge inside the system, and that is to pull the refrigerant out, weigh it back in, the charge according to the data plate, line set length and height if necessary, restriction in airflow of the evaporator on the heat pumps. It can cause the compressor temperatures to run high. So you're looking for a plug coil, possibly dirty filters. Once again, burnt wires. Also on this, if you want to see if your compressor's running hot, which we will have you do if we get in a P6 code especially, you want to pull that compressor blanket off, and you want to look and see if it's discolored. Looks like it's been hot. Maybe look at the stickers, see if they're melted. Any indication that something's been hot in there. And if it is, it's a good idea to just go ahead and replace the compressor. Sometimes you might get lucky and you might be able to ohm this out and see if the compressor's out, but usually it's more of a visual check. For ohming out the compressors, you want to look in your service manual for the correct reading. Bear in mind, these compressors will ohm out very similar to a three-phase, meaning all three readings will be very close. If they're even off by 10%, this could be considered a problem. So when in doubt, you might check it a couple times. In order to find out if you have the what your ohm reading is for the particular compressor you have, you're going to go here to find out what your model is. And then you're going to come down here, and this will be the model of the compressor. This is a model of the unit. and it's just blown up over here. And then you know what the model is, and then you can look it up on the next page and see what your own reading is supposed to be. Just remember, temperature does play a factor in these, as it does with most ohming out. Um, Checking your fan motor. There are two types of fan motors, and this kind of threw a few people for a loop. So I'll just give you a heads up. This is a test question. There are two types of fan motors, 5-wire and a 3-wire fan motor. If the fan starts, there's no need to even troubleshoot it any further. You want to check it, see if it spins freely. If it does not, obviously you want to replace it. If it doesn't run, or if it does run, there's no need to ohm it out. You know it's being told to come on voltage-wise. So you just want to move on. Now, when checking, and this here again is where you need your needle probes. I guess I don't like to, but in a pinch, if you had to use, some smaller wire because you didn't have needle probes, you can use a thermostat wire, strip it back, and put them in there. Sometimes you don't get as good of connection as what you should get. So when you're checking the 5-wire motor, the 5-wire, the control chip is in the motor. Excuse me, and you want to check between pins 1 and 3, and you should have between 200 and 380 volts DC. Now, once again, you're going to check your service manual for exact voltages on this. Then you're going to check for control voltage between pin 3 and 4, 5, and 6. With the unit in the standby mode, you should see between pin 3 and 4, 3.5 to 16.5 volts DC. Still in the standby mode between pins 3 and 5, there should be no voltage because the unit is off. Now you want to check between pins 3 and 6 with the unit off, and you should have 13.5 and between 13.5 and 16.5 volts DC. As long as you have these voltages coming off the board is good, and you need to replace the motor. You can check voltage at the board and at the motor. If you have voltage at the board, but you do not have it at the motor, then you need to look into your wiring harness. You can, check continuity on your wires that way. Now, when you're reading, these charts are in your service manual, and this is just a couple examples because they do change per motor and system. You want to follow the colors. The 5-wire, of course, here is index 1. And these readings are also affected by temperature. But 2 of these, you aren't going to have any readings between 2 of them. So you want to follow your black, red, yellow, blue to yellow. You'll have to know your motor, which motor you have. If you can't see it on the motor, you can find it the same way you did the compressor. Now this is the second motor. This one's 3-wire motor. And on this one, the chip is in the control board. And this one will ohm out like a 3-phase. And, on all this, when you're ohming these things out on the 5-wire and on the 3-wire, even on the compressor, do not forget to check for signs of overheating and also checking for ground. E1 error communication. If this happens upon startup of multi-zone system, you want to double check and verify your piping. There's several ways to do this. You can unhook all the heads but A electrically, turn it on. If it runs, refrigerant's going through the pipe proper, everything, and that one's good, and you just hook up the second one and just keep going down the line. You can also trace out the wiring and piping. Of course, we all know that's not always possible. You can also check it out for continuity by unhooking the wires, connecting them to each other, and just checking for continuity. You want to make certain there's no splices. Are any condensate pumps hooked up correctly? If you have any splices whatsoever, I can just about tell you right now, at some point in time in the future, you will have communication problems. Types of wire needed, 14.3 with the ground, 14.3 shield stranded wire with the ground with a 600 volt insulation rating. Power and communication wiring on the outdoor unit. It'll consist of the 4 wires. You'll have line voltage going through 2 of them, L1, L2, and then your signal wire will be communication wire, and then you'll also have your ground wire. Now, wiring between the indoor and outdoor unit is polarity sensitive. Now we're going to check for any interference on our signal wire. You want to shut the unit off. Remove the S wire from both the indoor and the outdoor units. Terminal block, and you want to position the wire where it's not going to touch any surface, but you can still access it. Set your meter to AC volts. Remember, our unit's still off, and you're going to check from the S wire to ground, and there should be 0 volts. If you have voltage, you're getting voltage from an outside source of interference, like a transformer on a fluorescent light, something like that. All these readings can be done at the outdoor unit, where it's just most of the time it's easier to work on. Now you want to turn your power back on, and you want to have your meter set to AC volts again, and you're going to check the S wire to ground, and you still should have 0 volts. If you don't have 0 volts, then you're getting what's called the transformer effect, which is what's affecting your wire. To test this theory, you can actually run a temporary wire. Just make it sure it's stranded wire. If you're just running temporary wire, it's not really mattered if it's shielded, but you want to run a temporary wire between the S's. Usually 14 stranded wire is the best. And if this solves your signal problem, then you know you need to run another shielded wire in between the units. If you have more than 24 volts on this unit, you'll have to run a separate. If you have more than 24 volts on your signal wire, you'll have to run a separate wire, because this is what's giving us the E1 error code. Just to kind of touch, if you don't know what this is, the transformer effect. When we're running these wires, how they're all twisted up inside the sheeting. So we're getting a larger electromagnetic field, as opposed to if they were just laying flat next to each other, you get a smaller one. This is what's causing the transformer effect, is power is essentially transferring between wires. Now we need to figure out which board is bad, indoor or outdoor board. With the S wire connected indoors and the S wire disconnected from the outdoors unit, and the unit powered up, you want to position. The positioning of your black and red leads is very crucial. You want to position your red lead on L2, and the S terminal will have the black wire on the outdoor unit. Now we're looking for negative volts DC with a little bit of pulsating. If you do not see negative volts DC at the S terminal on the outdoor unit, then the outdoor board is bad. Then you're going to switch it around, and you're going to put L2, your red lead, still on L2, but you're going to move your black lead to the S wire that is coming from the indoor unit, and you're going to look for pulsating positive DC volts. And sometimes this does run pretty high. But if you don't see positive DC pulsating volts, then your indoor board is bad. Now, when you're checking for communication, you're checking DC volts between L2 and S. You want to have roughly 15 to 60 volts DC. You can fluctuate a little bit over and under, but we don't want to go too much. It's a good idea to check this both indoors and outdoors. Uh, common communication error is you never splice, never break S wire or the L2. If you have to break the wires for a condensate pump or something, you need to break L1. Um, you can't use butt connectors or anything like this. Just no splices whatsoever. Now, sometimes maybe a local code would require a switch, and we'll go over a little bit more of that later. When landing your wires on the terminal blocks, you want to make sure you don't have any stray wires poking out. Make sure they're all landed good. And of course, this is not just for ductless, but this is for, pretty much all of our high voltage across the board. Now, if you have to use this for local codes, this is what you'd use. It'd be a 3-pole, 3-phase manual toggle switch. And you would run it where you got L1, L2, and S going through there and coming out. If you do not need this per code, do not use it. It's just another place where something can go wrong. So only use it if you must. Condensate pumps for ductless. Never wire in a ductless or condensate pump on L2 and S. If you have a condensate pump and communication issues, you want to verify the pump is obviously working and functioning correctly. And these little pumps are notorious for getting plugged up. The installation manual for these pumps is written for all brands of ductless. Therefore, they are universal. But on Carrier, Bryant, we do not break the signal wire. We always break L1. Down here, we got this L1. That would be where you would break it in order to shut the unit down if the condensate pump failed. If you wire it in with L1, then you should not have any communication failures because this wire is still going to be solid, your signal wire, and your L2 will still be solid. You won't have any splices. And remember, so never splice between the units. Splicing's bad. All right, now we're going to get into the other components like electronic expansion valve. The electronic expansion valve is controlled by algorithms in the board. So basically, it's its own computer, and it's designed to work at variable speed capacities with little needles. And in this case, this particular one is a 500-step staging valve. The coil, excuse me, the coil can be replaced without changing out the valve. It's a good idea. If it isn't acting properly and you suspect the expansion valve, make sure this is connected tight and it's not loose and vibrating around. You can check your voltage. We'll go over ohming it out here in just a little bit. Most of the expansion valves are either 5 or 6 wires. And when ohming out the expansion valves, you're checking. You're going to check the resistance, and you're going to refer to your service manual. Most of them ohm out at 50 ohms. But when you're checking your voltage, this is when you're really going to want to refer to your service manual because in this particular instance, CN18, CN19, and CN22 are your outputs. And you're looking for 12 volts DC on those. And it's going to be between pin 1 and 4. You're also going to have a waveform between 0 and 12 volts DC. And once again, you're going to need needle probes for this. I can't tell you how many times that they say, well, my probes don't fit, and we have to go get some thermostat wire and make it work. Now, they may not be exactly together. Like in this case, there's just a little bit of variance. So a little bit is okay. It's when we start getting a lot of variance that we start having issues. Um, Reversing valve or four-way valve. Remember, this is a high voltage, 115 volts or 230 volts, 2A, 230, depending on your unit. It is energized in the heat mode. In the defrost mode, it does follow certain algorithms. You can, for testing it, you're going to, test it with power on. Make sure you have 0 volts in cooling when it's operating. And when we're in heating mode, we want high voltage, whether it's 208, 230, or 115 volts. If it's not in this range, if it's not getting any voltage to the coil, then you're going to need to replace the control board. Now you want to turn off your power, and you're going to use your digital test meter, and you're going to check the resistances. And the resistances should be between 1.8 and 2.5 kilo ohms. So just so you guys caught that, that is 1.8 and 2.5. And of course, you want to make certain everything is open to ground. If it's open to ground, if it's not open to ground, you're going to replace your coil. Sensors, E1, E5, F1, F2, F3. Sensors usually operate between 0 and 5 volts DC. It's a good idea to, once again, just check your service manual for these exact readings. The sensors play a big role in defrost, fan speeds on indoor and outdoor unit, compressor speed, what it's operating at. Location of several of these thermistors: evaporator thermistor, return air thermistor, ambient temperature sensor, condenser coil sensor. That's not an extremely good picture, but it's going to it's the pipe going to the condenser coil. Sometimes these sensors are not always easy to get to. You may have to take off several, if not all, the panels. Here you're going to be wanting to check voltage. You're going to refer to your table in the service manual. And as you can see here on CN33 and CN8, these are both themistors. And you're going to be looking for, roughly 5 volts DC. Now on CN9, those are switches, high, low pressure switch. So you'll check those like, you do any other switch. Are they open? Are they closed? You'll refer to your an ohm chart, your resistance chart. Make sure, your temperatures and everything. Now, because it's still fresh in our minds, back in February, we had the cold spells, and we couldn't read some of these sensors. We had to wait till till the temperature got up to 0. But the majority of everything is controlled by the sensors, whether it's the fan speeds, the compressor. So if it's extreme temperatures and you can't get a reading on those, then you're just going to have to wait for something to warm up. You also want to remember that everything changes. The boards change when they get ordered. New sensors, they get changed. Sometimes, you need for them to match. So when you're ordering these, when you're talking to parts, you want to be certain that they are giving you the newest version. Most of the time that is what they give you, but it's not always available. Now the reactor, let's see here, checking your reactor, and turn off power, unhook the wires. This is just several pictures of different kinds of reactors. Basically, it looks like a big transformer, but you're looking for 1 ohm or under. If you have anything over 1 ohm or the reactor is opened or grounded, you need to replace it. So just remember, if it's over 1 ohm, you're going to have to replace it. P6, low pressure protection switch. If it's open, you're obviously going to want to see if it's stuck and check for wires. If it is open, you want to make sure you don't have a refrigerant leak. Dirty filters, indoor outdoor coils being dirty could cause low pressure protection switch to open. Some tips when you don't have an active fault code. Multi-zone systems, you want to be certain they are either set for heat or cool, not auto. They will not work if one is calling for heat and one is calling for cool. You want to check the batteries in the remote. Is the remote using the follow me? And I will get more into the follow me setting mode later. You want to verify that your outdoor unit has power. Check the product data sheet to see what the operating temperature ranges are. Refer to your load calculation and always take into consideration these are variable speed units. Couple more things is your refrigerant charge. We spoke about this before, but I'm going to say it again. The only way to verify your refrigerant charge is to weigh it out, weigh the charge out, see if it is the correct amount, and then weigh the charge back in per the data plate, adding refrigerant for the line length, number of units, height if necessary. Perform proper microns. If you need to, you can make the temperature adjustments on the compensation settings if you're overheating or overcooling. And always bear in mind that these systems do have a minimum run time of 7 minutes. And on multi-zone systems, you do have bleed by from the EXVs. Now, this is, see if you got a pin here. Obviously, this would be a situation where you're not getting a good connection because the pin is not pushed in with the rest of them. So you want to be certain they're seated good. In some cases, we visually look at it and there's the problem. And I think in this case, this was several boards went through this and there were slugs crawling around inside there. And they had random shorts across several boards. And I think it took a while to find it. I'm glad they didn't change the unit on this because it would have just had a problem with the new unit too. Sometimes you can always see the damage, but finding the cause of this damage might not be as easy to find as what the actual damage was. So now we're going to take a 10-minute break and just kind of, get our bearings and everything here. There's the QR codes. If you haven't signed in or if you haven't got the quiz yet, go ahead and get those copied or picture taken of, and be back in about 10 minutes. All right. Well, if we don't have any questions, we'll get back to it. If you do have questions, we can answer those at the end, or Craig can go ahead and just answer them as we go, and we'll just get moving on here. So, defrost operation. The T3, T4, the T3 ambient and the T4 condenser coil sensors, they're what mainly control the defrost part of this. If your unit, if your system's not defrosting, there's the obvious things you're going to check, which is going to be your refrigerant. Um, Also, you're going to want to check your sensors. Defrost is available. It says DF on the display on some indoor units. Remember, this is an algorithm. So there's not really much in the way of measuring it. We just ohm out the sensors. If they ohm out correctly, we have the proper refrigerant charge. Then we replace the board. When going into defrost, the compressor will continue to run. The indoor and outdoor fans will shut down. Defrost can last up to 10 minutes. And like I said, on some of them that do have displays, there'll be a DF on the indoor unit. So this would tell us. Not all units are capable of forced defrost. You want to check with your service manual to make certain. So if they are, they'll have a manual button. And you'll push it twice to enter force cooling. An FC will appear on the indoor unit's display. Press and hold the manual button for 5 seconds and to enter force defrost. So your indoor fan will stop. DF will appear on the indoor unit display. To quit, to shut this off, to quit the force defrost, you just push the manual button continuously again for 5 seconds. Here's some locations of the manual button on different units. These are the high wall systems. This is a console units, and under the ceiling units where the manual button would be located. Defrost on the manual buttons for the cassettes and the ducted. This is the IR, the infrared sensor. So there's your manual button, and basically this is a picture of this, except it's just an actual picture. Controls and compatibility. You will want to refer to your compatibility chart for your controls to make certain it works with your unit. Not all Wi-Fi controllers work with all indoor systems. Not all wired controllers. And when I say wired controllers, that is the 24 or is the thermostat that comes with that unit. So it is a communicating thermostat. If you want to use a 24 volt thermostat, you will have to install a 24 volt interface. All ductless systems come with a remote. The indoor unit has a remote, whether it's ducted, cassette, floor console, under the ceiling, air handler. They all come with a wireless controller, and it's a good idea that even if you're not going to use this, to put it in a nice safe place, because you may need it in the future. The follow me, I'm not going to read the whole thing. You guys can do that. Basically what it is the follow me, the mode senses the temperature at the controller. So whether it is a remote control or a wired controller, it would sense it at that place. If it is a remote control, it has to have line of sight. It has to be within 25 feet. in order for it to get the proper reading from the remote control. Now, if somebody walks by and throws a coat over it or something, after 7 minutes, it checks, there's no signal, and it goes back from the remote control sensing back to the return air sensor and senses it up there at the unit. And then once again, all you have to do is push the follow me button and it will take back over from the remote or the wired controller. I went over where the location of the manual button was back in the defrost section. Basically, it's just look for them. High wall units are located usually on the right-hand side. Now, once again, we're going to talk compatibility chart for your wired controller. You do not splice these. They just plug right in. They are communicating wires. If you splice them, you're going to have an issue. So you want to order the proper extension cable for however far you are away from your unit. Different Wi-Fi kits are available. And yep, I'm going to say it again. You check your compatibility chart to see which one is for your unit. The Infinity and Evolution systems come with built-in Wi-Fi. You might take that into consideration. 24 volt interface. This can be used with most 24 volt thermostats. When using a 24 volt thermostat, you'll need to refer to the installation manual on the interface kit for the settings that you'll need. You do not use a heat pump thermostat. Even if you have a heat pump system, you do not use the heat pump thermostat. You'll use the heat cool only thermostat, and let the algorithms inside that kit decide on what's going to happen and when. You want to bear in mind that the 24 volt interface kit is 8 by 12, and it's 2.5 inches deep. So, may not want to mount it next to your high wall unit. You want to order the proper cables for it. It is weatherproof. You do not want to extend anything, no splicing on this either. When using the 24 volt, you can use the 24 volt interface. You can use a heat cool thermostat. If you have the option of electric heat, 2-stage heat and single stage cooling thermostat, 5-wire. So you can use pretty much any stat with these, because the control of the 4-way valve is all in the algorithms of the 24 volt interface kit. Single and multi-zone unit, indoor units, their standard features, wire controller. Obviously, they all come, like I said, with a wireless remote control. You have heat, cool, dry, auto restart, louver controls, multiple fan speeds, the follow me, quiet indoor operation. Indoor fan rules for heating and cooling. This is pretty much straight across the board. It does change a little bit when you get into the ducted systems. So you might refer to your the service manual for that. Basically, in the heating mode, when the compressor's on, the indoor fan can be set for high, medium, low, auto. When the indoor unit coil temperature is low, the anti-cold air function starts, and the indoor fan runs at a low speed. This speed cannot be changed. When the temperature is lower than the set point value, then the indoor fan motor stops. When the indoor temperature then reaches the set temperature, the compressor will also stop. The indoor fan motor runs at a minimum speed, or whichever setting speed you have. And this is where the anti-cold air function is valid. Now in the cooling mode, the indoor fan runs all the time, at the speed that you've selected, whether it's high, medium, low, or auto. When the setting point is reached, then the compressor stops and the indoor fan runs at the minimum or the set speed. Anti-cold air function basically functions only by the evaporator temperature. The anti-cold air function works with both the evaporator and the ambient temperature sensors. So once again, this is where sensors will come into play at. Um, it'll give you a more, accurate feeling, more comfortable. The 40 MBC cassettes, he goes in the, grid ceilings. They have their own, sorry about that. They have their own LED and fault codes on their status. And then when you're wiring in for the louvers, it's plug and play. Just plug it in, and then you have another wire that'll come from up here and come down to your wired wall controller. And these are communicating wires, so don't splice them. If you have to extend them, then you extend them with an extension cable of them. The most common fault code is the EE, which is basically your condensate, whether it's a plug drain, condensate pump is not pumping, not level. Worst case scenario would be a bad board. The MBD ducted systems. If installed in an unconditioned space, you want to refer to your installation manual to see if any additional insulation is needed. This also comes with its own fault code readings. The good thing about these is you have your choice of bottom return or end panel return. Setting static pressure. Static pressure always needs to be set and checked on these. We can do this in several ways. On the 9,000 to 24,000 BTU, we either need to use the wireless remote control or the wired wall controller, and you can go through those settings in the installation manual, and it'll take you through it step by step. On the 36,000 BTU and above, you will use these little dials, and they're always set for default of 2, but with 4 being the highest. So if you have to adjust your static pressure on these, it is crucial that you do that. The 40 MBF floor consoles are under the ceiling. Once again, these also have their own diagnostics, and most of these diagnostics are roughly the same for each and individual one of these, but there might be some changes. The console, we have, we have a different blow pattern. You can either have it blow just out the top, or you can have it blow out the bottom and the top at the same time. And these settings are in here. And it's your dip switch settings. You can also have your temperature compensation, auto restart, louver settings, which is what I just went over, fan motor control. But, when I'm talking to you, or one of us is talking to you, we tell you, bear with us. We're looking at the wiring diagram. We don't know where that's specifically located. That's because these do not tell us where they are specifically located on the board. So we see them on the wiring diagram, but it's hard for us to translate to you as to where they are located at. Now we're going to get into the single and multi-zone high wall units. We have several different models of these. Some have the displays. You can barely see the display on these. Some don't. Obviously, you want to check and see what they are compatible with. Before removing the covers on these, you want to remove the screws. We don't always, sometimes the screws are hidden. Just be careful when you are removing them. On these high walls, sometimes you have to kick up the louvers and remove the screws. These are usually located in the back of the service manual for both the indoor and outdoor unit. It tells you where things are located at, sensors, screws, things like that, how to remove the blower or how to even remove the condenser fan motor. Installing a wired controller. This also varies depending on your high wall unit. This goes back to you want to check with your compatibility chart. You do not want to splice these. Wi-Fi, like I said, the Infinity and Evolution systems have built-in Wi-Fi, but you want to check with your compatibility charts to see which Wi-Fi would use with your unit, which would be compatible with your unit. Like I said, some high wall units have a display, others don't. If the display once again gives you like the fault code starts out at P, you want to just go on outside because that would be where your issue is. We do have minimum installation distances, but just remember that sooner or later somebody's going to have to work on this thing. So take that into consideration when you're doing this. And we went over the location of the manual button, and most of these are located on the right-hand side. Sometimes you will have to remove the cover. Drain lines. This particular photo or picture is set up for the gravity condensate. You don't want to pinch it. You want it as low as possible. You don't want to kind of like give it a trap. You don't want to do that. Obviously, you want to seal the hole, put the electrical wires, whole line set on top of it, just as long as you're not pinching it. And then cleaning. It is a good idea to get one of these cleaning kits so you don't make a mess all over the homeowner's house. The 40 MBA single multi-zone indoor air handler. It is only compatible with 38 MGR, 38 MG MAR, and 38 MBR, depending on the size. We have constant airflow, constant airflow algorithm, built-in 24-volt interface, so you can use a 24-volt thermostat. Once again, wireless remote control. You will use this wireless remote control to set static pressures. Once again, we do have the built-in 24-volt interface. So you can, if you don't want to use, if you don't want your electric heat coming on at the same time your heat pump does, you'll have to put in a relay, and I will talk a little bit more about that down the line here. Obviously, when you're running a thermostat, you're going to follow the installation manual from the 24-volt interface kit, and it's pretty straightforward. And then you're going to, you want to go into it, and you want to know what your settings are going to be. Your dip switches are going to be set at. You're going to refer to your installation manual for this. Like I said, because they vary between every unit. Once again, static pressure. You're going to remove that metal panel on the air handler and your little IR receiver, the little white thing there that had the manual button on it. You're going to use the remote control to set this. You cannot use a 24-volt interface to set that. It would have to be done with the wireless remote control. It comes default with the on SP1. And, like I said before, static pressure is crucial on these. See, if you got a 0.6 or above, well, we're not going to be operating properly. So it's always set and check your static pressure when it comes to your either your air handlers, on the hybrid systems, if you're going to install a furnace, ducted systems, you always want to check your static pressure. And this is a remote control that comes with the 40 MBA. And this is going to be what you set your static pressures with. And, once you're done, throw that thing back in the bag, take the batteries out and put it inside that air handler, because you never can tell when you might have to change out that board or change out that motor, and you might need to set those again. Here's your IR receiver, that little white box with the little manual button and everything on it. And you could put 5, 10, 15, 20 kW in these. It just depends size of the air handler, obviously. And if you want your heater kit to run like it would an emergency heat or a situation like that where it's not running with the heat pump, you're going to have to add a relay. If you notice, the TXVs have been removed on this model because we are using the EXV would be used from the outdoor unit to control this. These are all removed from the factory on the 40 MBAs. Now, when we get into the hybrid systems, you will need, these are only compatible with the 38 MARs. You will have to remove the TXV, and you got one of the two piping choices here and their numbers. You'll also have to install a 24-volt interface kit, and you will follow, the interface kit per the installation manual. And don't forget, you need to use a single stage heat cool thermostat only, unless you're going to have your auxiliary heat come on separately from the heat pump, and then you'll need to use a 2-heat single cool thermostat. Something to remember, you will the G setting on these will be your continuous fan. So on the hybrid system, the blower will run continuously. With the outdoor unit, will ramp up and down as needed, as what these sensors are telling it needs to. So you will have to set the continuous fan per your installation manual for your 24-volt interface. And that wraps it up. So there's your QR code for your quiz, sign-in sheet, phone number, text number, email. So any questions? We'll hang out here for just a moment, let you guys get the get your
you've got a rate in here. Hang on. I had one question that says, will the auto function work if a 24-volt thermostat is used? And as I understand it, Craig, if the only time we can really use the auto function with the mini splits are when it's a 1-to-1. Otherwise, we can often fall into a mixed mode error code. Then if we are using a 24-volt stat, yes, we should be able to program that into the stat and use our offset, our deadband offset in there. The other thing that we need to remember when using a 24-volt stat is we will lose the swing function, because there is, I'm not aware of any thermostat aftermarket that offers the swing function to bring the lower louver where it would move. So for a lot of people, that's not a big deal. Other people, they want that oscillating lower louver. So I hope that's got our question answered. I'm going to go back and see here.
Somebody had their hand raised. Is that the one you just answered?
I think it was that one, but I'm going to, Mark, did that get your question answered, or did you have another? I'm trying to find him where I can.
We program the stat that it comes with. That would probably depend on your thermostat, Mark.
Oh, okay. There we go. The second question, hang on, let me address that first one. Can we program the stat that it comes with to disallow the auto mode? Well, yes, we do not have to go into an auto mode. In fact, usually that's a button that you press to enable or disable. Mm-hmm. I would be, Mark, what I might do is, again, my email's on the chat. You might email me your particular model number, and I might be able to help you with that. The other question, so if you can do that for us, Mark, that would be helpful. Why does the auto function not work with a multi-head system? It can work. The problem is if we have heads in two different rooms, and we have one that's calling for cooling and one calling for heat. It's not like the VRF system. We cannot do both functions at the same time. So it locks up the unit. It doesn't know what to do. And I call it the cat eyes. It just has two little dashes on the indoor screen, or indoor LED display. So it just will not allow it to work. So with a multi-head system, we recommend not using the auto mode. At the very beginning of each season, we get that call a lot. They turn it on, and both indoor heads, they just have two dashes on the screen. So that's what we find happens with that. So the next thing, I did have a question here about the Zoom Lock flare fittings. I'm actually kind of a fan of the Zoom Lock, especially if you have a large job. The VRF, I think it's almost imperative to do it when you're running that much pipe throughout like a school or a commercial building. I would recommend, always using a torque wrench and a backup wrench on them, but I'm kind of a fan of the Zoom Lock fitting. That's a good question. And then we have another one here that's directly about the quiz, Craig, and it says on the quiz, it asks about how many ohms on the reactor, but I don't remember you hitting on that subject. He did. There's a particular slide that covered that. We do not want it to read open. We do not want it to read to ground, and it needs to read less than 1 ohm. Anything above that, then we need to start looking at replacing that.
Yeah, anything over 1 ohm, Josh, and we need to replace it.
Correct. And then we got one over here in the chat from Steve. So what do we do with the test after completing it? Yes, it should, now, unless you've printed it out and filled it out manually, then copy it and scan it to me, I suppose. But if you filled it out online as we went or on your phone, we receive that automatically, and it scores it automatically as well. I think that's it.
Any more questions? Now, we do have this available in the PDF form. So if you would like that, one of us can send it to you. Well, actually, any of us can send it to you, any of the 5 of us. So, yeah, if you're interested in the PDF form of this, just let us know.
via email. That way we've got a correct email for you that we can just immediately copy and paste it into and return it to you. That'll be the easiest. So if you reach
There's
out,
one, Steve.
did I miss one? Oh,
No, he wants one. Um,
I got, oh, right there. It even came in. Okay. We can do that. So, okay. Thank you everyone for attending today, taking time out of your day. And we definitely appreciate it. It helps us on our end when we got guys that tune in and want to learn. And we're always glad to help. But I think there's a lot of great information in what we had here today. He definitely crammed a lot into 2 hours. So thanks for your patience, and hope you guys have a fantastic spring. And we'll look forward to listening or to hearing from you.
yep. Thank you guys.